Hi, my name is Vitaly, and today we will talk about things you learn in electric circuits course and why are they important in the development of future technologies. I'm from the Electromagnetic Systems Group at the Technical University of Denmark, and here you see my email, so if you have any questions, you are very welcome to contact me. We will talk about signals, components, and circuits. We will also look into the future of the technologies, wireless technologies mainly. I will present you my group, what we are doing, what our students are doing. And we start with signals. And you know that there could be different kinds of signals. Sine waves, square-shaped signals, and even very complicated shaped signals. And they can be used for different things. And in wireless technology, they are primarily used for communications to transfer information. They can be used for sensing, like car radars. They can be used for wireless energy transfer in microwave ovens, and also you can use them to power drones. Some of the drones don't even need to have a battery anymore because the energy can be delivered wirelessly. Another important concept is the Fourier transform. You know that Fourier transform relates signal in time domain into the frequency domain. And this is a little bit artificial concept, but it simplifies a lot our understanding and analysis of the signals. If you take a radio and tune to a certain radio station, you will see that there is a certain number associated to it. Here it's 100.7 megahertz. This is actually a frequency of the carrier signal which carries the information of this radio station. If we talk about components, one example is an inductor. And you know, if you push a current in the inductor, this current will generate a magnetic field around it. And of course, there will be a certain voltage drop across the terminals. If you take two identical inductors and place them close to each other, they will share the magnetic field and they will share the signals. And this has a very wide variety of applications. One application in medical imaging, magnetic resonance scanners, nothing else as a one big electromagnet. And the way it works is that the patient is placed into this magnet, and it is excited by RF transmitter connected to an inductor, which generates magnetic field. When the tissue of the patient is excited, it generates the electromagnetic energy, which is again collected and detected by the inductor, and the current goes into the receiver. The recorded data is then used to produce an image, and the example of the image you see on the right upper corner of this slide. Two coupled inductors can also be used for wireless charging. And if you remember from your basic electromagnetics course, the inductors can be coupled only if you have alternating currents. In order to generate them, you need oscillators. And on the left side, you see some examples of the oscillators which can be used. The same technology is used in radio frequency identification. You use two coupled inductors every time you pay for something with your credit card, or you pay for travel using HiSecort, using the near field communication system. Another important component is a filter. And example where you can use a filter, if you choose a certain channel on your TV, certain channel typically associated with a certain frequency band. So there is a filter which is tuned to this band. And in order to choose it, you need to have a filter. So let's talk a little bit about the future of the communication systems. And you all have heard that the next generation of communication systems is called 5G, fifth generation. And for the first time, the focus now not on the bandwidth, but on latency and the number of devices which can be connected. Low latency is extremely important in the new technology which is coming, which is called self-driving vehicles. You know that all the cars in the future, they will not need to have a driver. The next big wave in wireless communications coming is called is associated with the Internet of Things. So each and every small device in your house will have one or even several wireless communication devices which will connect this device to internet. So as you can see, even though you will not maybe choose to work within wireless communications, it's very good to have a basic understanding of the technologies. And the electromagnetic systems group at DTU is dealing with these types of technologies. We are 6 faculties. Some of them you have seen in some of the other courses, but we are a much larger group. And on this slide, you see examples of companies which we have dealt with, we cooperated with. Many of them are communication companies. Some others are working with radars. We cooperate a lot with space agencies, Europe and in US. Also, some of the companies are hearing aid companies and many others. We mainly focus on high frequency electronics, on front ends of these communication systems, but we also experts in antennas and propagation properties of electromagnetic waves, as well as how these waves are interacting with different scatterers, with different bodies. And this has a wide variety of applications from communication to sensing to energy transfer. And we are working not only with theory of electromagnetic waves, but also with antenna technology and measurements, as well as microwave technology. And we have a large park of measurement devices which we can use to characterize the circuits we are developing. We work with terahertz electronics, and we developed electromagnetic metamaterials and metasurfaces. We work with cutting-edge technologies not only in our research, but also in the teaching. So we try to formulate our teaching courses and projects such that the outcome of the project is typically a paper, a scientific paper. And in the next few slides, I will show you some examples of the courses we had in the previous years. Thomas, for example, has developed W-band subharmonic mixer, which is the core for next generation satellite communication systems. W-band is signal around 86 gigahertz. Daniel has developed a detector for carbon-13 imaging and MRI, and Aladdin and Marius has developed coils for 7 Tesla scanner. This is the scanner with the strongest magnetic field you can find in Denmark. We also like to use new technologies in fabrication of our devices. And Ruben has used so-called additive technology or additive manufacturing technology, 3D printing in metal to fabricate his antenna. And the results were so nice that it was actually decided to publish it as a conference paper. So if you have any questions regarding what you have heard here, you are very welcome to contact me or some of the teachers you have seen in this presentation. And if you want to have a basic understanding of wireless communications, I would strongly suggest you to take this wireless communications course, even though you will not decide to pursue your career in this direction, but it will give you a very good background knowledge which you will use in whatever career you choose in the future. See you hopefully at some of our future courses.